let's continue with chapter 7, where we talk with the pipelines. And we will use, as we go through this chapter, I will include some of the previous concepts we talked about as review so that you guys can be more comfortable with it. And this is something that we will talk about as we go through the chapter. So to say, after this module, you'll be able to explain the motivation for Kafka Connect, list the commonly used connectors, explain differences between standalone and distributed mode, and then configure and use Kafka Connect, and then do what's called single message transforms. So there's some interesting things you're learning in this chapter. But we'll first start off with talking about what is Kafka Connect and why do we even need Kafka Connect, right? And you'll see there's some really, really good use cases for this. So the whole point is there's no reason to have to write your own programs to bring data into Kafka, right? If you have this tool, or if you have a tool that is created that can make that happen for you. So it's always better to use the open source tool that a lot of people have already tested, and you don't have to worry about it. You can just focus on what you need to do as far as moving your data in and out of the cluster. So this is very important. So when you look at this page, you say, well, we just allow you to focus on this, focus on copying the data. You want to get the data into Kafka, you want to get the data out of Kafka. And then this other silly analogy when I say batteries included. So in other words, the note that we gave you is a Kafka platform should include this framework and includes the most popular plugins for import and export of the data. So there's a lot of different connectors that people have already written, and it's already there for you to use. Like if you buy an item and the battery is already included, it's easy. You can just turn it on and start to use it, right? So this is something that's very important. And then standardize. Well, when you're dealing with frameworks, you should standardize the task of importing and exporting the data. So this is not a solution like a one-time only solution. And so it's another, again, another note for you. And then parallelism, right? Whatever framework you use you should be able to parallelize the workload to bring the data in. And then you should be able to scale. And so connectors allow you to do all of these things. And when I say, what is Kafka Connect? When you look at pictures online, it always looks like as if you're looking at a different entity or something like that. Oops, let's see, hold on just a second. For some reason, my pen may be not as charged. So my apologies. Just give me 1 second, please. Okay, so when you look online and you look at most of the documentation, you'll see the Connect is a framework. In other words, it's really just a process, right? When you're dealing with Kafka Connect, it looks like a separate framework, but you have these concepts of what they call source connector and sync connectors. Someone writes the source connector or someone has written the sync connectors. All you have to do is learn to use them. There's no programming necessary, right? There's open source. The Kafka Connect API is there available for you. If you have some development experience, you can write your own connectors without any problems. We have, in this course, we don't show you how to write the connector, but we do have videos online that shows you, it walks through about maybe 1 to 2 hours, I think about a 2-hour video that shows you the details of how to use the API to write your own connector, if you want to write your own connector, right? But first, we need to understand what a connector is. So if you look at this picture, see the data source is on the left-hand side. And then when I use a connector, so this is most likely, not most likely, but if you're bringing the data into Kafka, you are what's called a source connector, right? So just think of this way. You have a source. That means you're bringing it from a database or from some other environment, and you're bringing it into Kafka. So source connectors bring the data into Kafka. And then you have sync connectors. So sync connectors take the data from Kafka and take it out to an external system like Elastic or HDFS, Mongo, wherever you want it to go. There's probably a connector written for it. So the first thing you would do is just search for the connector, see if you have it. And if you don't have an existing connector, then you could probably write your own, right? But there are jobs. It's just, think of it as just a process. Don't think of it as some separate entity, right? And we'll look at it in more detail. So source connector, again, you bring the data from external source. So that means if you remember my first description of a producer, so producer is literally any application that can produce data to the Kafka brokers, right? When we said to Kafka, we're saying to the brokers. So if a connector is bringing the data into Kafka, it's a source connector, that means it must have a producer, right? So internally, the source connector is really a Kafka producer. And if the connector is taking the data from Kafka and moving it out to an external system, then guess what? Anything that comes to read the data from Kafka is a consumer. So that means the sync connectors must have a Kafka consumer, right? So again, remember, any application that is consuming from the brokers is a consumer, must have a Kafka consumer. Anyone producing must have, it's a producer. So if you think about it in that case, it's really straightforward. Then when you look at this picture right here, give you more information. It's just for illustration purposes. If I'm bringing the data from a database, right, and I'm bringing it into Kafka, I need to be able to understand, okay, let's say the database has tables and those are timestamps. So what am I considering to be the offsets in this case? So when you're looking at, right, if you have this, as in this example showing you that's coming from the database, the timestamp from the table is what's going to be translated into the offset in Kafka. So basically, each of those records, imagine you have the A, B, C, D, E, as you can see right there. So the offset is like the timestamp, because we're storing this data into Kafka, but the timestamp is considered to be the offset. And if you are going from Kafka on the bottom image to something like HDFS, then the offset is just part of the file name. As you can see, like on the right-hand side, right? I see the offset is there, part of the file name. So like file 02, that means the data that is in that file called file 02 has whatever data that was in offset 0 and 1, right? I mean 0, 1, and 2, as you can see, 0 to 2. And then you have the next file is 3 to 4. So if you're not familiar with HDFS, remember this, HDFS is a distributed file system, and it's used to store large and large amounts of data, but it has a single point. In other words, it has a single server called the master. The master server is called the name node. And this name node is a single point of failure. So there's always a standby name node in a production environment. But when you want to write data to HDFS, let's say I have to contact the name node and say, hey, name node, yeah, here's my file. And I want to write this file to all the worker nodes, where we call data nodes in HDFS. And then the name node is the one that gives you back instructions. Say, okay, here, Hussein, you can write to node number 1, node number 3, and node number 6, something like that. And then my job is to now take my file and send my file to those systems. But HDFS will break up the file. The default block size for HDFS is 128 megabytes. So it will break up the file, and then it will replicate the file. In other words, each block of the file will be replicated. And I'll show you guys an example of that a little bit later. But for now, when someone says write to HDFS, that means you have to contact the name node. The name node gives you data nodes in a cluster that you can write to. Then you take your file, blocks of your file, the default block size broken up, and you send it to one data node. And then that data node replicates it to the next data node. And then that data node replicates it to the next data node. And then once all the blocks of the file has been replicated, then the name node stores that information into memory, right? And that's a very important thing to, so whenever you want to read the file, you go to the name node will look in its memory and say, oh, you want to access this file 02? Oh, yeah, there it goes. Go to this data node in the cluster. They have the blocks, right? And then you will go and read it from those data nodes. So HDFS is not very difficult to understand at all, but you will see it often in your work, during your work. This example says, yeah, we have CDC, change data capture. So if I have data coming from the database, bringing it into Kafka, or I can have from CSV files, comma, separated values. I have files, I can bring the data into Kafka, and then from Kafka, I can move it out to Hadoop or move it to any of these different places, right? So very, very powerful. These are examples, use cases, as you can see up here. And then I said, why not just use producers and consumers? Because you may say, hey, I'm a great developer. I want to write my own consumer and my own producers. You can do that, but why? If someone, especially if so many people have contributed to write, or test the connectors and it already exists, use it. And if it doesn't fit your need or if it doesn't do what you want to do, you can even customize it, right? Unless it's some kind of proprietary connector. But if it's open source, you can customize it and make it do what you want. So it's not, you don't want the one-off tools, right? You want to have something that's fault tolerance, tested, and all the buzzwords as you see on the right-hand side, okay? So if you can avoid writing your own connector, then you want to do that and just use existing connectors. Then I said, well, what kind of type of connectors do we have? If you look at the chart right here, right, you'll see that there's a lot of different connectors. We have this page called the Confluent Hub. And if you go there, you'll see that we have different kinds like source connectors, sync connectors. You can check the box that you want to say, this is the kind of connector I'm looking for. And you can see all of these things on our web pages, right? So Confluent Hub is very useful. And we have connectors listed in other places, right? So you have over 100 Kafka connectors here, plus more, right? Search through the filters. It's confluent.io/hub, right? So you'll see all the connectors, and we'll talk about how you can install the connectors coming up in just a second. So if you're using Confluent platform, it's very easy to just say Confluent Hub space install, and then whatever the connector name is. And it's very easy to install. Very, very easy to install. You guys will do this in the lab, by the way. You do something very similar in the lab, okay? You'll be doing it through the control center. And then if you have from other sources, look at this. I could get a jar file. And if you're not familiar with what a jar file is, remember jar stands for Java Archive. So it's very much like the tar command in the Unix world, right? So when you see a file that is a jar file, that means someone has included whatever application or the libraries they needed in this one jar file, typically, and then it's easy to deploy this jar file in production. And so the jar file, in this case for the connector, you can get the jar file and just, install the jar file on all the what we call the worker machines. I'll talk about that in just a second. But instead of using a class path like they used to use, you have basically this thing called the plugin path. You just say, hey, look, here's where this plugin is, right? And then you just say, here's the path, and that's it. And this allows this is the best way of doing it, because in the past, if you were using just a class path, and maybe you had, let's say, different, let's say you're a developer, Martin builds a connector and Lee builds another one, but they're using different versions of that same library, and you just use a class path, there could be an error. But this way of doing it with the plugins is easier, because you just say, look, yep, plug in the path, just put it where it's supposed to be. Very simple instruction to install. So installing connectors and setting it up is really easy. And then now, but we want to understand, we still don't know what a connector, I'm sure most of you still, it's general ideas so far, but we'll get to the nitty gritty of this, okay? Because it's just really just a process. And we'll talk about it in more detail coming up in just a second. So Kafka Connect reliability and scalability, right? So to add resource to connect, you simply start more workers. Well, what are workers? So we have to come back to this concept and understand what this is to begin with. And now let me see if my pen is ready now to be used. My apologies right there. Let's see this. So, there we go. I think it's now perfect. So there's this concept of workers. What is a worker? Well, think about this. Just like consumers in a group, a worker is like a JVM process. Just a process. You have to spin that JVM or that container, whatever it is. You have to start it. And worker is what will run the connectors and the tasks. So workers run the connectors and tasks, right? So it's just a process running here in this. The whole concept of connector is just, you could say process or service, but it's really just a process. And you have to spin up this worker, right? So let's say I spin that up, and it's just a JVM, and I will start my connect process. And then I just configure it to say, okay, I want you to be, if it's a source connector, then I just give it the proper configuration. And then this one could be a sync connector. So I just give it the proper configuration that I want it to have. And then when these processes are running, if it's a source connector, then it will pull the data from whatever database and then bring it into Kafka cluster, into your Kafka cluster. If it's a sync connector, it will be able to pull the data out from Kafka and then take it out to some environment. But it's basically you instantiate the, startup, not instantiate, but you create a worker like the JVM process, and then you basically start off the connectors, and then the connectors runs the tasks, right? So reliability and fault tolerance. So if a worker fails, just like consumers within a group, they're working together. So if one worker dies, as you can see right here, then another one will complete the work, just like the consumer group protocol, right? So this is important. If the individual tasks or connectors fail, then the users have to, then you have to decide how to proceed with that. That's doesn't. Now, all connectors support at least one semantics, but some does the exactly ones, because it depends who writes the connectors, right? And we will talk about this in more detail as we go through this coming up. Now, this is a little bit tricky, but let me just summarize what we've talked about so far. So you start up this thing called a worker, and we'll see this picture again. It's just like a JVM process. And then you install your connectors in the system, right? So think of it as just your service that you're installing or whatever it is. Connectors will run the tasks, right? You can have multiple connectors around. And then if this is a source connector, you will send configuration through the REST server to this connector to configure as the source connector, and then it will be able to bring the data from database into Kafka cluster, right? And if it's a sync connector, you just send the proper configuration, it will be able to pull the data from Kafka and move it out to an external system. But you have to provision these workers. And now, that was the previous page that we saw. But so what is this concept of partitioning now? This is confusing for some people because they start thinking about Kafka brokers. Gang says usually one VM equals one worker. Yes, you can think about that exactly. So you can have like a worker that can now run, but the worker can run multiple connectors. So I could have one worker running many connectors in here. But of course, in production environment, that's not great because then if my worker dies, right, too bad. So in the production, we'll see that we will run in this mode called distributed mode, where you have many workers. And when you have different workers and then different connectors running, then now they're just like consumers within a group, but these are connectors. So in this case, they're all working together with the same group ID, just like consumers. So then if one dies, then the other ones will take over. So this connector will move, and we'll see this coming up. But yes, so this is important to know. Just think of the worker as the JVM process that you will start, and we will come to that. So with this in mind, hopefully that helps. Then you say, well, what about this partition? What is partition here? Partition, as we talk about the data, you want to understand that we're not really talking about partitioning on the brokers, right? We're talking about the fact that, hey, if I have a database, and let's say the database here has, let's say 4 gigabytes worth of data in the database, then let's say this is, imagine these are tables in the database. Each one is like 1 gigabyte table, 1 gigabyte table, 1 gigabyte table, 1 gigabyte. So there's like a table that has 4 gigabytes. So if I'm a connector, if the worker, running this connector is going to read this, just like a consumer, this one task will have to process all of those 4 partitions. But if I have 2 tasks running, guess what's going to happen? Imagine that there's 2 tasks running. What do you think is going to happen? Anyone? So I have a worker. The worker is running the connector. There's 2 tasks. And I have a database here that has 4 gigabytes. And we're thinking about looking at it. You want to look at the tape, like the size of the data. So it's like we're partitioning the data. And if I say there's 2 tasks that are going to be running, the connectors, there's 2 tasks, correct. So you'll see that each task would take like 2, this task would take like 2 of those gigabytes, and the other task will take the other 2. So in other words, it splits the load just like consumers in a group, right? And this is why when we talked about consumers before, I said that protocol, the consumer group protocol, is something you will see throughout Kafka, right? And so that's what this is just talking about, the partitions, like you're partitioning whatever data source you have. But that's, again, the word partition is overloaded. And that's what in the same picture here that we just saw. So if I have tables, right, then imagine like each one is like 1 gigabyte, I say 1 G to make it simple. So that means you can think of it as 4 partitions if you want to, but remember, it's just an overloaded term. And if I now have connectors running with tasks, like 1 and 2 tasks, imagine if I have 4 tasks, right? 4 tasks, then each task, they will split the load. Each task will take 1 gig. So whatever the data size is, like if this is a file, and this file is 1 gigabyte, and I have 2 tasks, 1, 2, then each task will take, this first task will take about 500 megabytes, and then this other task would take about the other 500. So regardless of whether it's a file or a database, they split it up, and that's what we talk about partition. Oh, and here's the picture. Sometimes I forget what course has what picture, but here's the picture that we have in this one. And so same thing I was talking about. So pretend that here's your Kafka cluster, the brokers, right? So you have the brokers in your Kafka cluster, and the brokers have all the topics and partitions. Then I set up my connect cluster. What does that mean? Then I set up certain workers, like I have a worker, and this worker is maybe running this task, and I have another worker, and that maybe this one is running this. But I have, let's say I have those 2 workers. You must have a worker. So connect cluster is made up of workers. So this is my brokers. Then I will have these worker machines here, worker, and running the connectors and tasks. So in this case, I have 2 tasks, like this 1 task and this 2 tasks, something like this, right? So since the data from the external system, if this is a database, or whatever the external system is, you can ignore the word partition here, but imagine that this is like tables, and each table has like 1 gigabyte here, 1 gigabyte, 1 GB, 1 GB. Well, the job of the task is to split up the load. So this task says, I'll take this, and this one says, I'll take this and this. So they're splitting up the load, but we say partition. But don't get it confused. It has nothing to do with the brokers, with the partitions on the brokers, right? We just split up the load and bring it into Kafka. And then when we bring it into Kafka, we write it into Kafka, into these Kafka, topics, the different topics. So Gangliam said to everyone, task equal consumer in a group, consumer group in this context. No, think of it this way. So let's see. Because remember, like we saw with Kafka Streams, for example, how we saw that the Kafka Streams application has consumer right? You have a thread. The thread has consumer and producer, but you have tasks that are running as part of that, right? So this is the same thing. So think of the, yeah. So if you think of it this way, know that we have this worker machine, we have the connectors, and then the connectors will spin off the task. So here's this, like I say right here. One connector can have many tasks, right? One worker can have many tasks, and it's a task per thread. And typically the thread thing typically ties to your CPU. How many cores, right, do you have? So it's typically a task per thread, but so that's tied to your cores, right? So if I have multiple cores on my box, then I'll be able to say, oh, I can run with many tasks. Because if I only have like one core and I say, oh, spin off 10 tasks, it's not really going to do that. So I need to have the number of cores to support that because it's a task per thread. And this is, so this is, yeah, very good information to understand. So let's go on to this one. Then we say, well, what are the source and sink offsets? Well, this is like what we're talking about because Kafka, remember, just like consumer, when they're processing the data in the logs, consumers need to keep track of the offsets. So they say Kafka Connect tracks the producer and consume, in other words, produced and consume offsets so it can restart in a correct place. We know that it's very important. So if I'm a connector and I'm bringing the data in from a file, then what offset, how do I know what the offset is? So if I'm bringing the data in from a file, then my offset is just a position in the file. This is my file, and I read this record, this record, this record, and maybe I'm here. So this is my position in the file. You know, just like in C programming language, right? You can seek to any position in the file. So there's always a file pointer to know where you are. So if it's a file, you know your position in the file. If it's a database, right, the offset is like the timestamp or sequence ID, right? And it depends who writes the connector because you could write it and determine, I mean, typically there's an API to follow, but the method of tracking the offset depends on specific connector, right? You could write it and say, I'm going to do it this way or a different way. So the examples of the source and sink connectors, they said JDBC source in distributed mode, that's a special Kafka topic, and sink, and HDFS sink, you pretty much use as an HDFS file. In other words, how do you track the offsets when you're using a source connector or when you're using a sink connector? That's what this page is trying to say. And a lot of theory so far. So what we're going to do now is get to the point where we see it. We're actually going to see more detail how to configure it. Once it's pretty simple, but you want to avoid running in standalone mode. Standalone mode is, notice, it's a one worker on one machine, right? So you don't want to do that. One worker on one machine. You want to avoid this standalone mode. It's only good for like testing purposes and it's not distributed. So you want to work in distributed mode. That's the way you want to go in production. That means I have a certain number of workers. I spin up a certain number of the JVMs. These are the workers, and they all run like consumers in a group because they will have a group ID, right? And then they will run the connectors and the tasks, connectors and tasks, right? I'll just do it this way. So this is what I want because this is fault tolerant and scalable. If this dies, no problem. This dies, no problem. This dies, I still have one left. And I can always add another worker, right? Give it the same group ID. So you can scale up very easily, right? So try to avoid the single worker, doesn't really help you much. And in standalone mode, this is, again, notice here, they say run in standalone mode, start a process by providing as arguments. So I will start the connect standalone, and then I give it the properties file that it looks at for its configuration. But notice that each connector instance runs in its own thread. So here's the JVM, and here's the connect thread that would be able to connect to Kafka. But this is standalone mode, right? So we want to get away from standalone mode, and we want to go into distributed mode. So in distributed mode, notice I started Kafka Connect on each worker node. And when I say worker node, because you have to provision these nodes like containers or VM or whatever it is, right? You have to have, let's say I have my containers or my VM, whatever this is going to be. And then I start the worker process on those. And then I will be able to now start the connect on each worker. So once I start the worker, then now I can use this connect distributed and then point it to the properties file, and then I can start the connector process on each one. And then the connectors, the simple configuration to say how many tasks it has and what's the group ID and stuff like that. But all of these will now run with the same group ID if I want them to work together in the same cluster, right? If I want them to work together in the same cluster, then I give it the same group ID. So now I have this worker here. I have this another worker, okay? And I started to connect the process on the worker. And now remember, this process is either going to be a source or maybe a sink, right? Source or sink. But if it's a source, that means it will be pulling data from some source and bringing it into Kafka, right? Bringing it into, this is not the Kafka cluster, this is your connect cluster. So if it's a source, it would be bringing the data into, let's say here's your Kafka cluster here, Kafka. So if it's a source, it will be configured to bring the data into Kafka. If it's a sink, it will be configured to come and get the data from here and take it out to somewhere else. Sorry, it's a little messy. So let's just know that it could be a source or sink. Okay. Let me know if you guys have any questions. I'll continue to go. But here's another one for if I have multiple workers. This is just looking at the failover. So in this case, notice there's 4 workers. So imagine that they're all running with the same group ID. See, all of these workers here have the same group ID. So now they're like consumers in the same group. They have the same group ID. So that means they will discover each other and they will work together, right? All of those workers are like consumers in the group. So 4 workers, 3 connectors, A, B, C, and then A connector A, as you can see here, I'm sorry, this one is not going to connector A. I was thinking about that. So you have there connect 1 has the task 1, connect 2 has the connect 2, task, notice the task associated with it. So connector 1 has task 3, connector, so they can be spread out, right? And then when you look at this picture, if one of these things fail, like here, a worker fails, this one dies, notice that the connector that is running on this, and you see what happens here. See? So if we look here, that was connector 3, and then connector 3, task 1. So notice connector 3 moves on, okay? Connector 3, task 1. So it's taken over by a different worker. Just like consumers in the consumer group, the work must go on. So that rebalancing or that task assignment is performed by the worker, not by the connector, right? It's by the worker. The worker does it, okay? And so the same, there's links, and so it's pretty straightforward in this case. Then he said, well, the worker, when you're running distributed mode or in standalone mode, you need to be able to configure them. Now, they need to be able to communicate with the brokers so they can bring the data into the broker or move the data from the broker. So you need to be able to contact the broker. You need bootstrap servers, right? And then we'll talk about converters in just a second. The converter, this is the converter class for the key and converter class for the value. Because remember, we're always working with key value pairs in Kafka, majority of the time. And then consumer, notice, because if you are bringing the data in from a database into Kafka, you are a source connector, then what does that mean? That means you have internally, you have a Kafka producer. And then, well, that means if you have a Kafka producer, then you can customize the producer properties, right? So you can see that's why this one is showing this example. Say, look, producer batch size is doing one of those customization. The point to this page is to let you know that you have some properties that you'll be able to customize just like you do in your regular program because you're writing internally. I mean, you're using a producer, right? But it all depends on, there's a lot of interesting things that we'll see coming up, but we'll talk about it more. Let's look at this one. Configuring the workers, standalone mode. That's an offset storage file name. But again, try to avoid the standalone if you can. I'm just going to go to the next one. This is what you want to focus on, distributed mode, right? Even if you are just doing testing, still run in distributed mode. Even if you have one worker, it's better to run in distributed mode. But if you look at this, the workers have a group ID, just like consumers in a group. And remember, consumers in a group, they have a session timeout because they have to heartbeat to the group coordinator to make sure that they're alive, right? And if they don't heartbeat within a certain time, then there will be the group coordinator will think that it's dead, and then that's going to be like a rebalance, right? So all of these things, session timeout, group ID, heartbeat, right? And then, but because it's in distributed mode, config, it has a configuration storage topic, just like what it sounds. So you will be able to store the configuration information for the connector and task. So you'll see that you can send this information using, through the REST service to the worker to configure the worker, and then the worker will store that information in this Kafka topic. So you don't have to reboot this worker to get the configuration, a new configuration passed to it. And then you have an offset storage topic, right? To store the offset for the connectors. And then you have status. And then you have this concept, topic creation able, to allow the source connector to define topic creating. So the default is true because remember, the connector is bringing data into the Kafka topic and it wants to be able to write to the topic, right? So if it cannot write, then it won't be able to produce data into those partitions. So these are properties that you have. And if you ever had to, for whatever reason, create it yourself, you want to keep in mind to say, well, if I'm doing this myself, I want to be able to give the right number of partitions. And we still have to talk about this because before you guys leave this class, you want to feel comfortable and say, hey, Hussein, we have this new project and we're working on this thing. We're going to create a topic, 1 or 2, 3 topics, but how do we know how many partitions we should have in a topic, right? You guys we will discuss this a little bit later, but instead of just guessing, there's a recommendation that says, look, we'll give you some guidelines on how to figure it out. But on this page, what we're trying to tell you is this, right? These are the recommended number of partitions. If you have to do it manually, as far as creating the topics, then give the config storage topic 1 partition. And for the offset, give it 25. And for the status, give it 5. And there's also a whole bunch of internal topics that Kafka uses. And you don't have to memorize all of them, but just know that for the most part, let Kafka handle it unless you decide to change things differently. So configuring the connectors are really easy to do if you're using the UI. If you're using the UI, this is pretty much this. And by the way, guys, one thing you should know so far is you don't have to know anything about development to use connectors. Connector is more of a DevOps or administrator's role because it does not require any coding. You do everything through configuration, right? So this is what's great because your administrators can set this up for you, or anyone can set this up for you in your environment. So configuring connectors with Confluent Control Center You can see that it makes it very simple to come in. As you can see here, like it says, setting up the connector. How should you connect your data? It tells you this once you use the JDBC source connector. Give it a name, the name. How many tasks do you want to have? See? And well, of course, you want to have the right, if you don't have a lot of cores, it's not really going to give you the number of tasks, right? So really easy to configure through the Confluent Control Center. And then, but not all the time are you going to be using the Confluent Control Center. You want to be able to configure this just by sending the, sending the configuration information over the REST API. So you could do that, right? So in distributed mode, you can configure by the REST API. And then remember, we have that config storage topic. So the configuration information will be stored in Kafka on the brokers, in Kafka in that special, in the config storage topic. And you can, if you are configuring this, and let's say I have 3 workers, I can send my configuration to any one of these workers. Because remember, the worker will eventually store, any one of them will store it into Kafka. So it doesn't really matter which one I connect to, but they will store the configuration information into Kafka. So you can make a REST call to any worker, right? And you can do that. If you're doing standalone, that's not going to persist the changes, right? But with the Kafka distributed mode, you send your changes and it will be persisted into Kafka in the config storage topic. Okay? So just know that you can add connectors, you can modify connectors, you can delete connectors through the REST API. And in your documentation, you'll see that the port that it uses is 8083, right? And it's very important. So the changes will be stored in Kafka. And then when you restart, when you start your worker, they will all be able to pick up the changes. Okay. The configuration is stored in a special Kafka topic, as I just mentioned. And those are the key important points that you want to keep in mind. Hopefully you guys are doing good. No, it's still early in your time, but let me know if you have any questions. Okay. Hey, did you guys know that there was an exam? Your management is going to give you an exam after this course? Did you guys know that? I just got the memo. I said, Hussein, administer this exam before the students go. That's no one has fallen for that. Not possible. Okay. Just want to make sure you guys are there. Okay. So, well, Tate, I'm sorry. I don't know if you were saying something, but here. No exam vouchers. Unfortunately, no exam vouchers. Yeah. Okay. So with this in mind, now we'll go on to this part. So using the REST API, some important REST endpoints. You could do get, you could do post, you can do, again, if I say get on connectors to get a list of active connectors, I could create a new connector with post, and we'll see some examples of this. I can get configuration for a given connector, and I can create a new connector or update configuration. And it sometimes is really much easier once you start looking at the commands to make this happen. So I want to get you guys closer to that. When you go to configure the connector, connectors have name, right? They have like the name. There's a connector class. You can figure out how many tasks do I want. There's key value converter, and then stuff like topics, list of input topics to consume from. So you can pass, it allows you to do some configuration. And you can also, like they say, override connect worker properties, right? Because by default, when you set up the worker, here's the worker that is going to run my connectors and my tasks. Worker will run my connector, and my task. Oh yeah, question. Oh, okay, I'm sorry. I thought it was a question from. Okay. What are the considerations to determine task mask? That's a good question. I would say number one, let's say if we come back to this picture here, your task maximum task to create. The connector may create fewer. Just like I say, if it cannot achieve the parallelism. So in other words, if you don't have a lot of cores in the whatever container or VM that you're running in, you will not be able to create as many tasks as you, like say, if you say 5 tasks and you can, but now if you say, well, how do I know when I want to have tasks? Because remember, the task is going to split the load, let's say from the database, right? So if I have, depends how much data I have in this database. If it's just like the tables are not that huge and they're no big deal, one task could probably do that job, and you could probably look at the time associated with that. But if I have gigabytes, let's say I have 10 gigabytes of data in here, and I know that my box or container, whatever system I'm using, has like maybe 4 cores. Well, I mean, you can always test this out. Like the default is 1 task, but if 1 task is bringing in 10 gigabytes of data, your time to get that data into Kafka may be a little bit, but then maybe the time is not that big of a deal for you. Maybe you just started off and it's going to finish up in 1 hour. So maybe it's no big deal. But if I know that I want to go faster and I have the 4 cores, yeah, I definitely want to increase my number of tasks. So this is the kind of stuff you do. And then that way, of course, they will split the load, right? They split the load, and then you should get faster process. So I would say it's definitely tied to your data and how much cores you have, but also how fast you want to get that. Everything's tied together. So hopefully that makes that helps. And the question says, in distributed mode, that will be the total worker cluster core. Let me see. Oh, 10. Maximum task to create, the connector may create it. No, so this will be in distributed mode. Ooh, that's a very good question. I will double check by looking at the ABI, but I'm pretty sure this is for your, because this worker instance could be on this physical machine, right? And now if I have only 1 worker, if I have 2 workers, yeah. So yes, so I believe that it will be the task mask across that group, but each one, when you set these up, I believe that the num task that you could specify is across. Yeah, I have to, sorry, my memory is a little bit foggy with that specific configuration, but I think you're right when you're talking about the total number of tasks. But remember, each one, this could be a physical machine that is running a worker. So that depends how many tasks, depends on how many cores I have on this box. Yeah, but good, very good question. Actually, I never heard that one before. Let me put that in. Task masks. Yeah. So, but as long as you're comfortable right now to say, number of tasks ties into the, your cores, and that ties into like when to consider how much I need to bring in. That's definitely something you want to be aware of. And then I made a note for myself about that. And I will definitely look that up while you guys are doing your lab. Overriding connect worker properties. So by default, worker configurations apply to all connectors, like we were just talking about. So if I have a worker configuration, like perfect example, like that task max, right? But this applies to all workers connectors that is on this worker. So by default, like if you set security, it applies to all the connectors that are here running on the worker. So sometimes you want to be able to override things. And it's like you can customize a connector setting with this property, connect client config override policy, right? And then it works, overrides the worker configuration with producer, consumer, or admin prefixes. And then you can say none to use just the worker settings, or principal to override security settings, or all to override any prefix setting. And you can create your own custom connector client config override policy class. Now, this is just something that's giving us notes, just let you know that when you look at the documentation, you'll see that it's pretty straightforward as far as how to set these things up. But just note that the configuration applies to all the workers on all the connectors on the worker by default. So if you want to override something, then that's what those properties are for. Let's see. Single message transforms. So this is actually really, really amazing. But at the same time, you want to be careful with this, right? When I say what is single message transform? Single message transform, think about this. I want to bring the data into my Kafka cluster. Here's my Kafka cluster right here. And remember that a lot of the things that people do in production environment is filtering and cleaning of the data, right? In some way. But typically, what do you do? If you have a producer that produces the data to Kafka cluster, then you could have a Kafka Streams application that brings that data into its topology and then does some filtering, do whatever you need to do, map, flat map, filter, and then write out the data back to Kafka. And then you could have consumer that comes to consume the data, right? But if I'm using connectors and I bring the data in from the database, I can bring all the data into Kafka, and then I can still have my Kafka Streams application do some filtering and then produce the data back to another topic in Kafka. And then I can then use the connectors to move the data, Kafka connector to move the data out to some other source. So if I'm using connectors, I can still have my Kafka Streams application do the transformations or filtering of the data. But then you say, okay, well, Hussein, we already know that. We did that yesterday with Kafka Streams, so we know that. Okay, but what if there's some kind of requirements that say, okay, we're not using Kafka Streams, or maybe you don't have developers on the team, but we still want to filter the data before it even gets into Kafka. Here's the database or wherever environment. The data is coming, we want to bring it into Kafka, but we want to filter a whole bunch of stuff, right? We want to throw a lot of things away, filter. Or we want to do some masking, for example, like credit card numbers. I say, so whatever your credit card number is, we want to like mask out this field. We don't want this number to be written into Kafka. We want this to be masked before it hits Kafka. So in Kafka, it doesn't, it has this format here. Well, guess what? You could do that with what they call SMT, single message transform, right? And this is beautiful thing. So I bring the data from its database using Kafka Connect, and then the single message transforms will take effect before I write the data into the brokers, into whatever format. And then when I'm bringing the data from the broker using Kafka Connect, I will also do the SMT to convert it back to the format that it needs to be in to be able to write it out. And we'll see this example coming up. But the whole point to this is, what can I do with SMT, like masking sensitive information, like I just mentioned, credit card or patient record, whatever, tax information. You don't want the identifier. You don't want it to be written to Kafka like that. Add identifiers, tag events, lineage provenance, like data centers, what data centers coming from. Remove unnecessary columns if you want to. You're dropping an entire column from your data set. Maybe that's the column that has the user, maybe that's the column that has a user credit card number, right? You're dropping that entire column. Or you can modify the event going out, route higher priority, direct. So lots of things you can do. Cast the data type, remove unnecessary columns. All of these things you can do, right? And so where does the SMT want to talk about single message transform? Remember, no coding necessary. But then the problem is also important here for you to realize, even though it says no coding necessary, you do this all through configuration, you need to be careful because it can be very cryptic. Oh yeah, question, sorry. Oh, I'm sorry, I thought it was a question. Okay, So it can be very cryptic, even though there's no coding necessary. So if you find that you are doing a lot of SMTs and the configuration is pretty cryptic, we don't really go into a lot of details of the configurations, but sometimes it looks almost like a sendmail configuration file, right? But one of the things I'll give you guys at the end of the day today is I'm going to give you a documentation with to my Google Drive. And you don't have to have a Google Drive to access it, but it will give you all the links to stuff like the connectors. It's like a 9-part series to how to do these SMTs. Really nice short videos that'll make you an expert. And again, no coding necessary, but it takes you through step-by-step process of learning how to do it. So in this picture, right, we can see how the single message transform fits in. So you have the source connectors. As you can see in the picture, they're reading the data from the external system, bringing it into Kafka. And then notice that when you first bring in the data in, the data is in whatever format that it came from in the database, right? So the connector needs to translate that into Kafka Connect, what they refer to as the generic data API format. And then you guys will see these notes in your documentation as well. But then once it's in that generic format, then you can do your single message transformations to change the field, to mask it, to drop a column, whatever you want to do, right? And then after all of that is applied to it, then the data will be passed over to the converter, which is going to serialize it into whatever format you want, like Avro or JSON or Kafka, and then it will be able to write it to the broker. So that's the role that the converters converters are like serializers, right? To convert the data into whatever format, like JSON or Avro, that will write the data out. So if you needed to just keep it in simple terms, all of these things are done behind the scenes for you. You don't have to even worry about it, but it's just giving you more detail about how connectors work. But you'll see towards the end and in the lab, when you do it, it's just going to be really simple. Add the configuration and it just works. But if you need to know what's going on under the hood, this is exposing a little bit more of the internal, so to speak, right? But here is the single message transform details. So insert a field, replace, mask, value to key. Some important one like extract the field, extract specified field from the struct, and really useful stuff. Regex router or timestamp router or set schema. So some really useful things. And these are things that I haven't played around with as much because I don't have a need to, but I tell you, they're very powerful if you want to. There's some other ones, flatten, cast. This is a filter like we were talking about before. You can do filtering without having to write a Kafka Streams application. So you filter out records matching or not matching particular predicate. So this is powerful because you can filter out a lot of records before you put the records into Kafka, right? So you don't have to. So let me just repeat this one more time. Most of the time, people bring the data into Kafka, and then they have some kind of consumer application or Kafka Streams application, consume the data and do whatever they want to do with the data, and then they will produce it back to Kafka into a different topic, right? And then now that data is ready for other microservices or something like that. But if I know that I don't need a lot of those records, or I want to filter out the data, it's so important. It's an important step. So if I'm using this single message transform, I could go ahead and use a filter, for example, and filter out a whole bunch of stuff, and then just bring the data into topic already, and it's going to be ready to go. So my other services can just access that topic as is. So I think it's very, very powerful, but you don't want to be too cryptic. You want to make sure that you do not there's a fine line. I don't know if you guys have ever worked with morph lines. Anyone knows about something called morph lines? In the big data world, like in Hadoop world, used to use morph lines. Well, morph lines is something that you use. It's like coding through configuration. It's like you have to build a huge configuration file and you don't have to write code. But the thing is, it will get so cryptic that is very difficult to follow. So if you find yourself doing a lot of stuff that's really difficult to follow, you may want to not use the SMT and just perfectly write a simple KSQL or Kafka Streams application to do what you need to do. But it's very easy to use this in connectors, like I said, converters, provide whatever data format written to or read from Kafka. They're decoupled from the connectors, but you don't have to worry about it. It's just showing you, I bring the data in custom format. Then when I do my single message transformations, then my converter knows how to work with the schema registry. It understands my data format that I need to write out to Kafka, whatever format I need to write out. Okay. So this is just some internal processes. I'll let you guys read that. Nothing, it does not affect how you use the connector. It's no big deal. It's just, then converter data formats. The converters apply to both key and value, right? And then predefined data formats for converters, like you have it for Avro, byte array, JSON, JSON schema, protobuf, string. It's just saying, look, these are all choices you have when you need to write that data out to Kafka. And as far as using it is concerned, look how easy it is to use it. So to use it, all you have to do is in your connect properties file, like all the stuff we've been talking about for the last 10 minutes or so, it boils down to just this. Go to this properties file and just add this, like I say, key converter. I say, here's the Avro converter. Then I say schema registry URL, give it the URL to my schema registry. And then look, value converter, put the name Avro converter. Then schema registry URL, go to there. All the stuff we just saw is taken care of just by doing that line, right? All of this part now, the converter knows how to now communicate with this schema registry, and then it will be able to write the data to Kafka in whatever format. It makes it simple. So it's not a lot of discussion, but when it really comes down to it, is there's a connect distributed properties file. So when I start the connect worker and I point it to the configure, it gets all this configuration information that it needs from here. And then it does all the job that we just saw before. It does everything for you. There's not much, but we still have to configure it. So here's an example now. We are going to look at the JDBC source connector, and we're almost done with this one. So they say the JDBC API is common amongst database, right? Based on the older ODBC from IBM years ago. But Java database connectivity APIs, it's very common for most of the databases. So you can go ahead and use that. So a great way to get the data into Kafka. And all you're going to do is, here's my picture. I have a database. You're going to pull this database to get the data out of it and bring the data into Kafka, right? This is your Kafka cluster. Oops, I should say Kafka. This is Kafka. So it's very simple to use. Each table will get its own Kafka topic, right? And then new and deleted tables are handled automatically. You will create a producer record for each row and you produce that record as a Kafka message. So it's really straightforward to use. And if we look at the example, there's this part we have to understand. Now, we know that we can use the connector, connect to the database. If it's a source connector, we send the configuration property, and we can now configure that connector on the fly. And then once we have this connector on and the connector's running, but I'm bringing the data into Kafka cluster, but how do I now capture the changes? Let's do this. Here's my database here. I've used the connector. I'll just put KC Kafka connector to bring the data into my Kafka cluster. This is Kafka. I'll just put a KFK. Okay, so now I have all the data written into Kafka across the different topics. But then what if there's new changes? Someone adds new entry to the database. How do I now pick up those new changes and bring it in? Because I don't want to bring all the data that I already brought in before. I only want the new changes in the database. I want to be able to capture those changes. So what I can do is if I use the incrementing column, is pretend that there are tables in the database. In this table A, let's say I have a column called ID column, and maybe it's a social security number column, and maybe this is a age column. I'll just make this up, and a whole bunch of stuff. But let's say in this ID column, it has an ID, and let's say this number is 100. And all of this data that was brought in before, the latest ID here is like the last column was 100. So if I come back to see a new change in this ID column, if it comes to 101, then this is now a new row that I want to capture. And how do I know that? Because I'm using an incrementing column. I check a single column where the newer rows have larger auto incremented ID. Does not capture updates to existing row. So there's a limitation here because it does not capture the update to existing row. What does that mean? That means if I had a row that was here before, this previous row, let's say row number 99, there was changes made here. I'm not going to capture that. I'm only going to say, well, this is now the new column here. This ID column here has ID 101. This is the new row, but I don't capture this. I need to be able to capture this as well because there's changes here. So in that case, the timestamp will be very handy. So incrementing column by itself doesn't do the job. So I can say I want to use the timestamp as well. So if I say use the timestamp, right, then I check a single column to capture rows. But if the task crashes before all the rows, same timestamp, then some updates may be lost. So by itself, the timestamp doesn't do a great job. I mean, it does a good job, but there's no guarantee because some updates may be lost. But if I put them together, I say use the timestamp and also the incrementing column. So I'm looking for, let's say if this is the ID column, I'm looking to see if this new row 101, this is a new row, perfect. But I'm also looking at the timestamp so I can capture some previous row that change, right? Like in row number 99, there's a change. So that's why people use this more often, right? And so then you can also run a custom query. I'm connecting to the database to bring the data into Kafka, right? I'm using my source connector, but I can also run a query, some kind of query on this database to select only the tables I want. Or I could do bulk mode to bring everything in. Bulk is like a full dump, right? Load all the rows in the table, does not detect new updated row. So these are some examples of things you can do with Kafka Connect. And then as far as the configuration properties is concerned, well, if I'm going to connect to the database, I need to know, well, what is the URL to the database? Right, that makes sense. What topic do I want to connect to? That's the prefix. Remember, prefix is in the front. What mode? Is it timestamp? Or is it just bulk or incrementing? Or is it timestamp and incrementing, right? So if I want to do CDC, I mean, there's a little bit more to do in CDC, but at least you want to make sure you get the right choices here. And then do I want to write a custom query? Poll interval, right? The frequency milliseconds to poll. And then the table blacklist, it says, look, what tables do I want to ignore? And then the whitelist says, look, what tables that I want to import? And this is in itself is a little bit biased, but that's the thing. So here's an example of what the configuration looks like, right? If you look at this carefully, here's the name and config, you see? So the configure, all the stuff we've been talking about is actually pretty straightforward when you look at it in the config. It's pretty simple. Like I say, look, config, I say, here's the JDBC source that I'm using, connector. And I say, oh, here's the connection URL. We saw that there's a property connection URL right there on the top line. So we saw this as a property right here. Okay, no problem. My connection URL, I say, hey, I'm connecting to the Postgres database. Here's the URL, and that's the Postgres database. Then it says, what's the connection user? Well, the Postgres is a Postgres user. Now, what table do I want? I want the driver table. Is there a prefix before, right? And I don't have a prefix here, right? And then it says mode. Then I say, okay, do the timestamp and do incrementing so I don't miss any changes. And then is there a column to use for the incrementing column name? Yeah, use the ID column. So remember, the column name could be whatever you choose. But if there's an ID column here, then you're looking at the rows. If this one was 99 and this one was 100, this is 101. And then if this is the new row, 102, then yeah, this is the this is the ID column here. So that's the whole. And then the table type is a table and then some other configuration. But you see, so all this stuff we've been talking about, guys, this whole class, I mean, not the whole class, but this whole lecture so far, it's actually pretty simple when you start to look at the configuration information. It makes life weird. And then this is an example of single message transforms, right? And this one is just something that we don't really explore as much because, like I said, there's a 9-part series that we have online that I will give you a reference to. So this doesn't really do it a lot of justice. And we put the notes here. But if you look at this first page, we're defining 3 transformations on the top, right? And we have like the suffix, the create key, and extract key. You could call them whatever you want, but in this case, we're doing that. Then in the next line, you see the transforms suffix dot type. This is, well, what type we're dealing with, right? So we're using this thing called the regex router. That was one of those options we had, regex router. And if you guys are familiar with regular expression, then this is perfect for you, right? We're using the regex router in this particular case, okay? So the regex class is this class that sets the Kafka topic name. And normally the topic name will be prefix plus table, whatever the prefix is plus the table. But in this particular case, right, we know that it's driver profiles. So driver profiles, yeah. And we give you a little example of this, right? So the topic name should just be the name of the table, which is driver. And this transformation is it replaces the driver with the driver profiles arrow, right? Now, if you look at the regular expression here, remember in regular expression, dot is any single character, right? And then if I put the asterisk here, the asterisk is 0 or more of what character come before. So this is 0 or more of the character that comes before the asterisk. Some people just say 0 or more of the previous character, right? That's a short way, but I like to just. So when you say dot star, it really says nothing or anything will match. And in regular expressions, when you group regular expressions in matches, if I have this typically tends to put it in like buffer 1. The second grouping typically tends to put it into buffer 2. So when you start to see things like $1, you know, it's like whatever that matches the suffix, you know. So you have to look at the documentation. This doesn't really give you, doesn't do like justice on it. We're just trying to show you an example of what the SMT, a single message transform, will look like. And then in the next one, line number 18, right, you have the class used for the create key transformation. So we use the value to key class, which is the class that replaces the default Kafka record key with a new key from the field in the table. And again, you will be able to read these examples in the book, but the whole point to this is an example of how you would do a single message transform and using a regex router, but the documentation takes you through a lot of great stuff. And the videos, we have videos that actually does it a lot of justice. This is not a developer topic, but this is something that's good to know because you can now coach your admin or whatever it is and give them a chance to do some great stuff. And let's see where we are. Hold on just a second. Let me just, oh, okay. I was going to see where we were to give you a break, but we're almost done with this. So let me just finish this up and then we will just take a break. and we'll take a break so you can do the lab. So HDFS sync connector, let's say if you're using the HDFS sync connector, it continuously pulls from Kafka and writes to HDFS. And they say integrates with Hive. Now I know a lot of you guys are new to this world of the big data and so forth, but when I was talking about HDFS before, HDFS is the Hadoop distributed file system. So it has something called the name node, right? I'll say name node. This is the master server of the Hadoop cluster. And then it has these nodes called the data nodes. Just like we have Kafka brokers, but these are called the data nodes, right? Data nodes. They run a daemon called the data node daemon, right? So remember how I gave you the explanation before? Each of these Hadoop nodes or these HDFS nodes have a whole bunch of storage attached to them. Very similar to the structure we saw with like Kafka brokers, but these are not brokers. This name node is the master that holds all the configuration information in memory. So when someone says write to HDFS, I want you to be very clear. The HDFS cluster means that you have a master cluster called a master daemon. This is the master called the name node. And here's the example of me writing to HDFS if I were to do this from the command line. Let's say I have a file called my data file. I'll say data X, that's my file name. And assuming that this file is 400 megabytes, and I want to write this to HDFS, I would do something like this at the command prompt. HDFS DFS minus put. And I said put the data X. And it says, where do you want to put this? And I'll say put it into, let's say, a directory in HDFS. Let's say call it my data. Just like when you do FTP or SFTP and you do a put to put a file to a destination, that's pretty much what the command allows you to do. But what happens now is HDFS itself has a structure, a file like it has a directory structure that looks like a basic Linux file system. And you can make directories and stuff in HDFS. So I have a directory in HDFS called my data, right? And you could easily, you make this before. But remember, whatever you make in HDFS is all really just metadata that is stored here in the name node memory, because the actual data is actually here on the disk. All the data is stored here. So when you write into this file system here in HDFS, that looks like I'm writing to my data, like this command, so HDFS DFS minus put, to put this file into my data. It's really coming to the name node. You connect to the name node. You say, hey, name node, I want to store my file called data X, which is a 400 megabyte file, in this directory called my data. But these are distributed collection of systems. It's not one system. HDFS is a name node plus all the other data nodes combined. And because this name node is a single point of failure, it typically has another node called the standby, so that if the name node dies, you want the standby to take over, right? So it will always look like this: name node and standby, and then all your data nodes. So when I connect to the name node to say I want to put this, the name node is going to give me the host names. Let's say this is host A, this is host B, host C, and host D. So the name node will give me back a whole bunch of hosts to say, hey, here, Hussein, you can write your file to A, B, and let's say D, for example. It says, okay, write your file to A, B, and D. So this is what Hadoop is going to do to my file. And I'm almost finished with this example. It's just really important. Because I have a 400 megabyte file, it's going to split this file into blocks, because the default block size in HDFS is now 128 megabytes. That's like your file system block. So what HDFS will do is say, hey, you have a 400 megabyte file. I'm going to split this into 1, 2, 3. So this would be one block. This would be like the first 128. This is block number 2, 128. Block number 3, 128. And then That's 384, and then that means this last block, number 4, is only 16 megabytes. That's not 128. So a 400 megabyte file would be split into 4 blocks here. And then what you're going to do now that you know you can write to host A, B, and C, you will send your blocks. So here, you send block number 1 to like A. Say, hey, data node A, here's my first block. Then data node A will make a copy of that block number 1 to B. Because remember, the replication factor in HDFS, replication factor is also 3. That means then data B will make a copy to D because we said we give the list of hosts. So that block number 1 is done. And then block number 2 needs to be done too. So the same thing will happen. You write to 2, then this data node is responsible for writing 2, then this data node is responsible for writing 2. And you write block number 3, this data node is responsible for 3, then writes the 3 to here, because you need 3 copies, and then you write the 3 to this one, 3. And if the host D was part of the list, if it added the C host to say, hey, here, you can also write to C. If the name node tells me I can also write to C, then of course, then let's say my last block here, number 4, I can say, okay, 4, this one is going to go here to this. This is block number 4. And then this 4 may copy to 2. To this B, and then B will copy the block number 4 to. The whole point of this picture is there would be identical 3 copies of every single block. And then the file is completed. And then the name node stores it in memory. It says, okay, I know block 1 is on host A. I know block 2 is also on host A. And I know block 3 is also on host A. And it also knows where all these copies are. Block 4 is on host C. So when a client comes to HDFS and say, hey, I want to read the data file, I want to read my data X, HDFS will give it the location to say, oh, go to the right host, and the client knows how to go and read that from the cluster. Sorry, I deviated a little bit just to tell you about this, because when you're working with Kafka, you will often see people talk about writing to HDFS. When someone says write to HDFS, that means there has to be a HDFS cluster set up with a name node and those data nodes. And you will communicate with the name node, and the name node will give you locations in the servers where you write your data. And then your data will be split up and replicated across those systems. But the difference is, in this example, is let's say I give Eric is the first person to get block number 1. Eric is responsible for making a copy to Lee. Then Lee gets a block number 1. Then Lee's responsible for making a copy to Martin. Then there's 3 copies of block number 1. So each data node in this case is responsible for making a copy to the next one, which is different from how Kafka does it. But you still end up with 3 copies of the block. So with this in mind, all the data is now stored on these servers. And then you say, well, what does this have to do? Why am I telling you about it? Because when they make a statement like this, integrates with Hive, Hive allows you to query the data on these systems. They have the data written on the systems, but this is not a database. So how can we query the data on these systems if it's not a database? Well, what Hive does is, right, you create something called the Hive meta store. So you basically have a database where you will create a schema for the data. You'll say create table, something like this, create table. And your table name is the same as the directory name in HDFS. So I would say create table, my data. And then I would say, look, I would describe like name is a string, whatever is an int. And I describe the data type, but that's stored in this thing called the meta store. So then when you come and write a SQL query, like I said, select star from my data, right? What it will do is it will look into this meta store, look at the schema, and then it will go to the HDFS directory here, my data, and then it will find this data X, and then it will go to all the blocks that are in HDFS, and it will treat it like a database, although it's not a database. I'm sorry, this is a little bit messy, small space, but I just want to let you know. So when someone says Hive, Hive is a high-level abstraction that allows you to query the data stored in HDFS, right? But HDFS is not a database. So how do you get to query that data stored in HDFS? Because you create a schema. You create something, the schema in the meta store. So a table in Hive is a directory in HDFS. And then the content of the table is basically the file in the directory. And that's the key. I know this is a lot to take. It's not a Hadoop class, but I'm telling you now that you will obviously come across some big data lake or some HDFS or something. And this is important to just understand the basic. So sorry for the little deviation, but every class I do this because we come to these things where people say, look, it works with secure HDFS and the Hive meta store. So you know now, okay, the meta store is just the place we create the schema. And secure HDFS is, again, it's just saying secure when you're running using security in your HDFS cluster. And then, yeah, and the rest is here. But that brings us to the end point where it just says, look, there's a lot of connectors out there. There's a file stream connector, acts on local file source connector tells the local file and sends each line as a Kafka message. Local sync connector appends the Kafka message to a local file. So it's just more documentation that brings us to the lab. And so that's a good hour and a half that we've spent on this chapter because we started that. And I know that you guys are very patient. So does HDFS sync need to communicate with Hive? It doesn't need to communicate with Hive, but what happens is this. It can integrate with Hive if you want. In other words, when you write the data to HDFS, you're only contacting the knee node and you're writing the data across those. So I'm contacting the knee node and the knee node's going to allow me to write the data across those data node, right? But now this does not create a schema for me. It doesn't know any schema or anything. So if I want to be able to update Hive, when they say integrates with Hive and allows auto table creation, then that means I will be able to update that meta store, like, in other words, where the schema is for Hive, and it will know about my data directory. So it will update it with the necessary information so that Hive right away, you can come and do something like select star from my data without having to worry much because you update you update everything ahead of time. So just know that if you're working with HDFS, again, it's whenever they say write to HDFS, that means you're contacting some name node and the name node's going to give you locations in HDFS where you can write the data. And then the name node will keep all that metadata in memory. And when they say update Hive, that means you have to update. Hive uses something called the meta store. And the meta store is what stores the schema. And then when you communicate with this meta store, if you can update it automatically, then you will automatically be able to query the data in HDFS without having to worry about it. That means you can write the Hive QL, which is like SQL. So I can write select star from my table. But remember that a table in Hive basically is the same as a directory in HDFS. Let me clean this up. So a table in Hive is the same as a directory in HDFS. So in the previous example that I use, a table in Hive will be equal to that, like that directory, like my data directory from the example that I used before. So when I write select star from my data, right? This is the data in HDFS. So table in Hive is a directory in HDFS, right? So if HDFS has a directory called my data, then whatever files are in this directory, like my data X file that I used as an example before, that means when I query this table in Hive, I'm basically querying this my data directory in HDFS, which means I'm going to the content of the directory, which is the file called whatever file that I have. And how do I know the format of the file? That would come from the meta store, right? The meta store, which is where I would have created the schema for the data before. So the meta store has the schema for the data in HDFS, because HDFS doesn't understand any data format. It's what they call schema on read, right? So that means when I go to use the data, I need to understand the schema at that point. And that brings us to the end. But yeah, that's just a little bit of synopsis, a little snippet of information that is important, because often people will say, oh yeah, this works with HDFS. Well, what does it really mean? Writes to HDFS, right? If you write to HDFS, that means you're contacting the name node, you're getting locations of blocks data nodes where you will write your block. And then if it says update the Hive table, well, that means it will be able to update the schema in the meta store so that you can know how to query that directory in HDFS, because your data lives in a directory in HDFS. And that's the overview of that part of it. But you guys will see this lab now. We'll take you through the step-by-step process. The connector lab is a lot of fun. As a matter of fact, they've used the scene lab in the administration course. I think maybe that's just a tiny, I'm not even sure if I think they're slightly different, but very similar lab. So with this lab, you have, let's see how much time you have.